Yeah, so welcome to yet another discussion on functional and non-functional testing. This video is going to be a very important one because of the topics which we are going to cover. So from previous discussion we can see that we have already covered the introduction part, and today we are going to deal with the types of testing where we'll focus on black box testing to start with. And afterwards we look into these topics such as test management and automation, generation, metrics, and the software test effort estimation techniques, right? To start with, what we have is this is like the broader umbrella where we have like black box testing, white box testing. Then in order to test the interfaces, we have something called as integration testing. Then we'll be testing the system as a whole, and then we look for these non-functional attributes, which is a crucial one, which is performance. Then we have like regression testing, and then we have ad hoc testing. So these many testings which we are going to cover. Now see, this is a list of different types of skill sets required for testing processes. Right, so in order to test, or in order to go for white box testing, what we have is we need to have the idea about the programming languages, because this time I'll be looking into the piece of code, right? So in order to analyze it, I need to have the idea about the programming language in which the system is coded. And in case of black box testing, I need to have the idea about the module functionalities, right? The overall module, its function, right? So these things should be known well upfront. Then we have something for integration testing, and in this, it's like we should have the idea about the module interrelationship. That means, if suppose there are like two modules, M1 and M2, and there is an interface, so I should know about the relationship. That means what values are passed, what values are received. These things should be known well upfront. In case of system testing, what we have is we need to have the idea about the real life deployment, right? Because this time we'll be only actually going for the deployment, whether it is on-site testing or off-site testing. For the sake of deployment, I need to have the idea about the real life scenarios or the real life deployment. Then we have performance testing. So in this case, I'll be I'll require the idea about the application, and I'll require the idea about the system tuning as well. Then we have regression testing, right? So this is dealing with functionality and the change management. Regression is something which is done at the end, which is like post deployment. Now post deployment, if suppose I get to know that there are some problems with the application, then I'll go for updation, and then I'll go for regression testing. It can be also sometimes the end user might ask for some extra functionalities. For that sake, I'll bring some modifications, updations, or deletions to the application. So in order to ensure that all these modifications, updations and deletions have not brought any adverse impact on the overall working of the application, I'll go for this regression testing, right? It is said like my system is under regress, right? For that sake, I need to have the idea about the functionality, and I need to have the idea about the change management as well. I should have the idea about the whatever changes have been made to the application. And then we have lastly the ad hoc testing. For that sake, I need to have the idea about the domain knowledge. So looking at these things, can we say that testing has so much variant, right? Testing has so much variant because see, so many things we need to know. So it's not a monotonous task. It's something which is dealing with many different verticals of any of the tasks. So to start with, what we have is we have something called as black box testing. Right? From the name itself, you might have got some idea that this is something where I don't need to know about the internals of the system. Right, so in this case I am only worried about the input, output can be a regular output, or it can be your error message. So in black box testing method, what we do is we look for the functionalities of the software applications. So we basically test it, and I don't need to know the internals of the system. I don't need to know the internals of the system. Whatever the code structure may be, I don't have to take care of. The implementation details, not required. Internal paths, not needed. So basically my black box testing mainly focuses on the input and the output of software application. And this black box testing is entirely based on my software requirements. Plus my software specification. Right, so my black box testing entirely based on these two things. This black box testing, in some of the literatures you will find that it is also called as behavioral testing. Why behavioral? Because here we are looking for your non-functional requirements as well. That totally depends on the kind of inputs, outputs, or how the system is behaving. That's why it is termed as your behavioral testing. Now let's see some basic details about it. So basically it is done without the knowledge of the internals of the system. This we have already talked about, right? So I don't need to throw any further light on it. And this involves looking at the specification. Yes, my entire black box testing relies on the specification only. I don't have to examine the piece of code, right? I can only deal with exe files as well, only. And it is done from customer's viewpoint, because as I said, non-functional requirements also addressed in this, so customer's viewpoint is also considered. And then in this case, the good thing is that even the independent test laboratories can easily administer black box testing, because I can pass on the piece of code to a third party vendor. I can pass on the exe files to the third party vendor, and this guy will be responsible for testing the product. I haven't shared the piece of code, I have only shared the product, right? So recall the principles of testing, where we said that it is not possible to exhaustively test a product, and test as much of the external functionality as possible. So external functionality here, once again I am talking about NFRs. That means I am dealing with black box testing. So in principles of testing, we have focused a lot on your black box testing. So basically black box is a bigger umbrella, and here the idea is to uncover as many defects as possible, and if possible use as short a time as possible. So what we have is like we have methodologies that choose tests that have a higher likelihood of uncovering the new defect. So idea is to come up with a particular methodology where we'll be able to uncover the defects easily. Now this is a daily black box test which we do. That means I have a lock and I have no clue about the internals of the system. What I have is I only have these set of keys. So what I do is that, let's say I have like similar keys, set of keys, I have like 4, 5, 6 set of keys, and in order to unlock these bunch of keys which are similar in appearance, let's say, so what we do is we keep on trying to unlock this particular lock, and the correct one results into the unlocking of this particular lock. So the internals I'm not aware of, hence it is like a kind of black box for which I'm giving some inputs in the form of your keys, and the result is the opened door which is in the form of unlocking the lock. That's what we do in case of your black box testing. We have like box, internals not known, keep on giving some inputs and analyze the output whether it is correct or incorrect. And in case of incorrect key, there is an error message in the form of not getting the success to open the door. Now let's talk about reasons for black box testing, because first of all it is done based on the requirements. Here we will be matching the requirements and then we will be testing the product, and it basically addresses the stated requirements, and along with these stated requirements there are like some implied requirements which are like some of the things which should be there in a software product, right? So those implied requirements are also tested. It can be in a form of, let's say, usability, it can be in a form of like appearance, right? So some implied requirements also gets tested with the help of black box testing. Then we have the good thing is that in this black box testing I am able to handle the valid set of inputs plus the invalid set of inputs as well, right? So valid set of inputs means the correct set of inputs, invalid like in which I am expecting some error messages from my application. Now the question arises like when to do the black box testing. So this is the testing technique which can be done right from the beginning of the SDLC, that is your software development life cycle, to the end of this entire SDLC, irrespective of what kind of SDLC model I am testing. I am choosing. Right, irrespective of what kind of model I am choosing. Now, the point is like how to do black box testing, right? Obviously, we'll be looking at some of the techniques, but here the point is how to do it. One is like in the initial phases, what we can do is that I can explain the requirements, and what I can do is like I can work on the specifications, then I can choose, I means here the tester, the valid inputs that would be for your positive test scenarios, and then I can take some invalid inputs as well, and obviously that would be for your negative test scenarios. And additionally, I also need to identify the expected outputs for all the set of inputs, whether it is valid or invalid. I need to construct the test cases. As a tester, I need to construct the test cases. And then what I will be doing is I will be executing the constructed test cases. Right. And then later on I can report it. Right. I can communicate it. And if required, I can fix it. Right. The errors, I can fix it. Now, these are some of the techniques of black box testing. Initially, we have like requirements based testing, and then we have like positive and negative testing. We have like boundary value analysis, where we'll be giving good amount of time. Equivalence class partitioning is also equally important. Your decision table is yet another important thing. And afterwards we have like state based testing, compatibility testing, your UDT, which is your user documentation testing, and the domain testing, which is leading to your ad hoc testing. So to start with, what we have is we have a requirement based testing, right, as it is a black box testing technique. So what we have is, in this particular case, my precondition for the requirements testing will be like a detailed review of the requirement specification, and basically this technique brings a better clarity to requirements. So what we do is like we validate the requirements which are given in my SRS. We look for consistency, correctness, completeness, and we also look whether it is testable or not, right? So what we do is we go for test requirements specification in this. So we have like SRS document, we look for your consistency, we look for your correctness, we look for completeness of this particular document. Now next is your positive and negative testing. So in this case, what we have is, for positive testing, what it says is that a product does what it is supposed to do, right? That means it's serving the entire purpose. And in case of negative testing, it's like a product does not fail when an unexpected input is given, right? So what it is saying is that I am giving an unexpected input and still my product is working fine. So that means it is giving some error messages, but yet it is able to deal with these kind of inputs. Now the next is the crucial one, where we will be giving good amount of time, which is like your boundary value analysis. So the test cases are designed with the boundary values, right? There is a rationale behind this particular thing. I will talk about this. And the rationale is that the inputs have high chances to find errors, right? The boundary value inputs. And using boundary values, the probability of finding the error gets maximized. The reason is that there are experiences from the past which indicate that error tends to occur at the extreme points. So it's like arriving at the tests that are effective in catching that happens at the boundary. So the boundary value means the maximum and your minimum values plus some additional values as well. Then probability of finding errors get maximized. So the idea is that sometimes due to time and budget constraint, it becomes impossible to perform the exhaustive testing, and that too for each set of test data, and especially when there is a large pool of input combinations. So we need an easy way or special techniques that can select the test cases, and for this what we are trying to do is we are coming up with boundary testing. So basically we are testing between the extreme ends or the boundaries between the partitions of the input values, and this extreme can be like, let's say I have this particular thing from A to B. This is the range of my input values. So I'll choose this value which is like let's say it is X, which is your minimum. Then I'll choose this which is like X, which is like min minus 1, right? I'll also take one X as your middle value, that can be for giving some basic idea about the product working fine by giving a nominal value as well, right? On top of it, what we have is like we have a maximum value which is your, let's say, X max, and I have like X max minus 1. Here I can also look for, let's say, plus 1 as well. Here also I can also look for this value as well. Now so what we are doing is basically we are looking for minimum, we are looking for just above the minimum, which is this one. We are taking a nominal value, we are taking a maximum value, and we are taking just below the maximum. So we are like firing these values, and we are looking for the extreme ends. Like you can have like start from end, we can have lower, upper, minimum, maximum, and the basic idea is basically like normal boundary value testing will be to get the errors by pumping in the values which are at the bottom. Now let's take one example so that the things will be much more clearer in this case. So what we have is like we have let's say a small program, right, or a software product where the purpose is that we have like A is any integer which is between 50 to 100, right? And a program P finds whether A is divisible by 4 or not. So in this case, what we have done is like did was like I took two extra values which were less than that, just to explain you. like based on this you have to follow these things only, but here what I have done is I took one extra value, right, which is like 1 less than 50, 1 more than 100, or else these values were sufficient. And I mean, then in that case, 99, 50, 51 and one nominal value somewhere would be sufficient. So what we have is, in case of 49, obviously I should get a invalid input message. In case of 101, I should get one invalid input message. And for rest of the things, I should get this expected output, right? These entries are filled after when we are testing the product, then these entries are filled. Now next is your equivalence class testing. So what happens is that sometimes your input domain, right, your input domain for the testing becomes very large. But we have to test for every input, right? So in that case, if we divide the input domain based on the common features, right? See, I'm talking about the input domain based on the common features, then we can reduce the number of test cases, right? So what we do is, in case of equivalence class testing, we identify the equivalence classes, and these equivalence classes, if we talk about number of equivalent classes, will be equal to number of test cases which will be firing, right? So in this testing, based on the number of equivalence classes, I will come up with number of test cases which we will fire, and I will generate the test cases. So in some sense we can say it is the generalization of your boundary value analysis problem. Right. So in equivalence class testing, or it is also, you can call it as ECP, which is equivalence class partitioning, what we use is that we group and partition the test input data, and that is done based on the number of different classes, and classes will be from the input domain and would be based on the similar kind of input values. So what we do is that before that, let's talk about the goals of equivalence class partitioning. So the goal is the completeness of the testing process, and there should be non-redundancy. That means that redundancy in the test cases should not be there. That means same kind of values keep on firing, right? So then that does not serve our purpose. Now what it says is that if suppose I have some values from the input domain, what I have done is I have identified 3 classes, and one data will be fired from this class, another will be from this class, another one will be from this class. So instead of firing so many values, what I have done is like one value from each of these classes are fired. And in case of equivalence class partitioning, we have like 2 mandatory classes. One is like valid equivalence class, another one is your invalid equivalence class. So this valid equivalence class gives me the valid inputs from this particular class, and the invalid equivalence class gives the invalid inputs from this particular class, and then we judge the output whether it is correct or we are getting some error messages. Now there are some benefits of equivalent class testing. One is like now I can reduce the number of test cases because I have to pick one value from each equivalence class, and there will be a good hit rate to find the maximum errors with smallest number of test cases, right? So there are certain benefits, and along with this there are certain issues as well. You may say that right now I am not considering the boundary values, and because previously we said that error tends to be at the boundary values, right? So in that case I'm not considering that particular point. Plus, if identification of the equivalence class is not correct, right? Because identification of the equivalence class becomes tricky, and if it's not correct, then our entire process is faulty one. Then tester might assume that the input for all the input data set is correct, which can become a great hurdle in testing as well. So let's take one example of equivalence class testing or equivalence class partitioning, and then the things will be much more clearer. We'll take the same set of software product which we took for boundary value analysis. So here also we are taking the same one, that a is any integer between 50 to 100, and a program P finds whether a is divisible by 4 or not. So what we have done is we have identified set of classes. 3 classes are there. One is which is less than 50, another one is which is in between 50 to 100, another one is greater than 50. So these two are from the invalid set of inputs, as you can clearly identify, whereas this one is from the valid set of inputs. And then we generate the test case by lifting values from each of the class. So what we have done is every time you have to draw this table, this only gives us the clear-cut idea. So each time I expect you to draw this particular table. So what we have is we lifted this value 25 obviously from class C1, which was less than another one is divisible by 4, but in practical you have to take only one value out of these two. And once again I have another value which is from class C3, and it's done. Now there are certain guidelines, you can call it, or it's certain rules for using this equivalence class partitioning. So the one is you should use the robust forms if the error condition in the software products are of high priority, right? Another one is you can use in the projects where the program function is complex. In that case we can rely on this equivalence class partitioning. And in order to ensure the accuracy and precision of equivalence class testing, so I need to define the input data in terms of your set of discrete values, because then only I'm able to classify that okay, these are the valid sets and these are the invalid set of inputs. And the team needs to select like one from valid and one invalid input if the input conditions are broken or not stated accurately. Another thing, a very important thing, is like to establish a proper equivalence relation. That's something which is very crucial. Now, along with this, there are like some benefits we have talked about, but additionally let me address some more benefits of it. Like we can observe that we have drastically reduced the number of test cases. If you compare the same problem of this nature for the same product, right, use this where we expect only 3 values to be fired, and here it's like nearly 5 values, right? I don't consider this one, expect 5 values to be fired. So there is like reduction of the number of test cases which are firing, and reducing the overall test execution time, because if I'm reducing the number of test cases, so I'm reducing the time, and then obviously then I'm minimizing the set of test data as well. And I can enable the testers to focus on like smaller data sets, which increase the probability of uncovering more defects in the software products. And I can this can be used in the cases where we have to perform exhaustive testing, and this exhaustive testing is something which is very difficult. So this was all about your equivalence class partitioning. Now we have another issue. Many times the input values, where there are multiple